Okay. Let me know if you can see my screen.
We can see.
Okay. All right. Good morning again. Thank you for joining for the ever so-called Ubuntu TechHive on this Saturday morning. Appreciate your time. Appreciate you coming in and join us to go through this. Ben is going to talk about kind of like part two of the API development that he did a couple of weeks ago. But before we get started, just going to share a few other tools that I've tried. Maybe it could be of interest for you as well. I mean, I've already talked about Notebook LM. I'm not gonna dwell too much into it. They've actually upgraded it. I haven't tried the upgraded versions yet, but they've upgraded it recently, so you can do. Apparently, you can do even a lot more. And I think they're even talking about oh yeah, see, Notebook LM Plus. So everybody wants a cut, right, of that pie, money. So I'm sure you have to pay for this one. So um, so I have not tried it yet, but if someone eventually tried it between now and when we meet again next time, that would be awesome. And tell us what you find. Last time I can't remember if I showed you Napkin. Have I showed you Napkin last time? I can't remember. But basically, what it is, it allows you to create graphics from text. So when you're doing your presentations and you want to kind of put some nice graphics into it, you can just come in here and then do a few prompts, and then it can give you nice visuals, and then you can accept some of the visuals on that. So it's actually pretty sleek, especially if you present a lot. That could be something you can look into. It's really nice. I just use the free version. There's too many things to pay for these days, so I just use the free versions for now. Have you seen this before? I can't remember, honestly.
No, we haven't talked about this.
Okay. Yeah. I tried it about a month ago, and it works. But it's nice. So that's napkin.ai if you want to grab the URL. So we actually talk a lot about OpenAI and ChatGPT, and we've also talked a lot about Claude from Anthropic. But the one thing that we actually don't touch a lot is the one from Facebook, Meta. So Meta actually has it's actually pretty nice. Their um, LLM, I guess you can call it, Llama. And I've tried it. I've tried it on a few things. I try to compare. For example, if I ask something to open ChatGPT, I try to ask the same thing to Meta. What I've kind of noticed is that Meta, the responses are a little bit more concise. It doesn't give you a lot of text like sometimes ChatGPT will do. And maybe that's just kind of like a configuration in the back end. But I mean, so far I've liked it. It's free. I would say, this is another tool you can put in your tool belt. Especially since the other ones you kind of have to, especially if you're working, let's say, with ChatGPT and then it's down. At least you have another option, right? So just something to think about. Anybody use this?
I've used the what do you call that? The models where I installed them on a physical device and tested it, and it's pretty good. But I've not used the Meta, AI tool, because they do build free models, open source models. Yeah, I've used quite a few.
So you actually downloaded the binary of this and used it in a device? Actually, is that what you're saying?
Yep, on the server.
Awesome. That would be nice to. That's a presentation for you, man. We can see how
that.
Yeah. Okay. That's awesome. So the other thing is, from time to time, I take some. Ben and I would take courses from time to time when we have time. Deep learning, the AI is also very good. They have some short courses, some long form courses, and most of them are free. So something you can kind of look into if you want to kind of upscale yourself in this field. Um, and it's not just about AI, of course. They have other things too. But yeah. So FYI on this. And Gamma is another tool similar to napkins, but what Gamma does, it actually creates presentation for you. So for example, if you have like a presentation in PowerPoint or Google Slide, you can kind of like upload it to Gamma, and Gamma is gonna redo it for you in a really kind of nice and um, AI-like um, way. So I've tried it. It's still a little buggy to me. I've tried it. It gave me a really nice presentation, but it's a little buggy still. I don't know if I can actually see what I tried. Oh no, it's can't access it. But yeah, so that's another thing if you're interested. I to me, napkin is pretty good with the illustrations. Gamma takes it into another level where you actually redo the whole thing. It gives a beautiful presentation, really beautiful. But sometimes it might be a little too much, you know, especially depending on the kind of like context you're in. It might be a little too much in terms of like the visuals. FYI of Gamma. And finally, I've talked about this last time actually. Um, if you remember Replit, we've used Replit before. So Replit is kind of like a platform where you can build. Um, it's an environment that's ready for you to build, to code basically, and it's all web based. And recently they've added a agent into their platform where you basically type up questions or prompt to build something with that agent. So a couple of weeks ago, I tried building kind of like a repository, I wanted to build my own website, and my own website also having YouTube URL that I can um, embed in the website. So I'm not necessarily hosting obviously the videos, but I just have a URL kind of pointing to YouTube, and and also just my personal website. So I wanted to try that, and he actually did a pretty good job. The only thing is, so one bug or something that it wasn't able to do was, if I wanted to post something on my website, for example, like a uh, an article or a video, I need to be admin, right? I need to be able. Nobody just cannot just come to my website and post something on my website, right? I need to be able to have like an admin page where I can go in with my UI, my credentials, and post an article. Somewhere, somehow, he was having a hard time getting to that step, figuring out how to create an admin page. You can see currently not getting access to, but it wasn't really. There was no authentication uh, possible. So you can see here, it says it would implement it, but it never really did it. So that's the only thing that I was struggling with. And that was kind of 9 days ago. I've never really gone back to do it. But if I can show you what it actually looks like, can I show it? Let me see. It did get pretty far. It spin up a Postgres database to store the articles. It did a bunch of things. Why is this? Oh, come on. Just 1 second. I'm trying to find they've changed the interface like since the last time I saw it. That's why I'm a little confused. It wasn't like this before. 9 days ago, they've changed it. Uh, oh, here it is. So this is kind of like, obviously I'm not lying, but so this is kind of how we created it. And I can go to the web view. anyways, that's what kind of what it looked like. It had the about, blog, videos, and then admin. It was not able to do the admin page, but it got the nice website. It's slick, I think. It does. It's enough for what it needs to do. So, but I had to pay $10 to have access to the agent. So yeah, they had a promotion going on, so I did that. And that's really it. Any questions on this? Any questions on any of these tools?
No, thank you for sharing.
For me, it's more about the first one. You mentioned something called Napkin. I never heard of.
Yeah, Napkin. Yeah, Napkin.
So it's for presentation?
Yeah, so it helps you create visuals for your presentation. So things like this,
Okay.
Yeah, visuals for your presentation. Instead of having a lot of text into your presentation, where people have to read a ton, this creates visuals from that text. So you just dump the text in there and it creates visuals. It will give you some options, and then you pick the option that works, and then you can edit it as you go.
Okay, Napkin AI. Okay. Thanks.
Yeah, I will drop all these links in the chat. So.
Perfect.
Thank you. So I do have something that I want to talk about too.
Yeah.
Can I still the screen?
Yeah. Okay, let me just stop sharing.
I'm sure you guys have heard of like stuff like ChatGPT, cloud, and all that stuff, right? Then you also have companies out there that came up with a business model to actually bundle everything for the price of one. Because sometimes cloud might work better for like programming if you coding stuff, and then OpenAI might be better for like writing documentation and all that stuff. So you want to technically have both worlds, right? But again, free is free until a certain limit, and then you have to pay for it. But with this tool right here, there's other ones out there too, but this is the one that I decided to give it a try. With this tool right here, it's a one subscription, and then it's like a $20 a month. But right now they have a promo going on for like $4 a month. So that's what I did, so I can give it a try. They're definitely losing money at this rate, but again, it's a trial, and then they're looking for users. And as you guys can see here, you have cloud, you have smart. This is probably their own model, GPT-4o, and then you have all this stuff right here. So you have a bunch, and then so you have all these. Where the lack so far, where they're still catching up is when it comes to agents, because they pretty much gathered agents that they believe users might like or might use better, and then they're building on top of those, right? They're adding them as they go. So I did do some research to figure out, how can they afford to give all these models for the price of one? And then just reading, this article right here, and then actually the CEO of U.com responded here. What they do, they're trying to get people so they can actually promote their tool and at the same time, give advertisements, right? So that's the long term. So because of that, they actually allow people to use the tool without any limit. And then because we all know that if you're using tokens with GPT, you're not gonna hit that limit in a day. So the $20 that we're paying for, like, let's say ChatGPT, is just way too much. It's more than what we would use for a day or like for a month. So what they did their math, and then they just figure out that if we just break it into like parts, we can just subscribe for all these for one, and then people would just come to us rather than going to each one of those. So yep, that's U.com. If you guys come across it, this is the tool right here. It's pretty good so far. I've used it, it's accurate, no issues at all.
Cool. I'll take a look for sure.
Yeah.
That's a pretty clever business model.
Yeah. All right, that's it from me.
You should go buy the me.com domain name that seems you.com is taken.
Is it actually available? I'm sure somebody.
I'm
already
sure
has.
it's taken already. Probably cost millions of dollars for that.
Yep. Yep.
All right, all yours then. If you're speaking, Ben, you're on mute. Ben. Nope, we cannot hear you.
Okay. What about now? Can you hear me?
Yep.
Yep. We can.
Oh, okay. So I think it's my mic that has an issue. Sorry. So let me move it out of the way. Okay. So I just shared the URL and let me share my screen. Okay, so is my screen visible?
Yep.
Okay. Well, what about the font size? Is it okay, or do you want bigger?
Can you make it a little bigger, please? Yep.
Okay. How is that?
One more.
Oh no. Okay.
That's good. That's good.
Man, it's really big in here. Let me close this one.
Well, yeah, it's up to you.
No, that's fine.
Actually, you can reduce it once if you want to.
No, that's fine. I can manage. I just have to close some windows. Okay. So I shared the presentation in the link. Actually, I can open it here. Okay, so who remember what we discussed last time? I guess no one. Okay,
We talked about APIs, contracts, contract first. That's kind of like what I remember.
right. So essentially, I can make a small summary of what we discussed last time. So last time we looked at how to implement an API endpoint from scratch, right? And the approach that we took is the one that puts the contract first, because when we have an API, essentially it's a contract between the client who wants to use the API and the providers who make the API available, who implement it, right? So let me run a demo here. I guess I should increase this one too. Okay, so let me see. Okay, so if I run this one, and okay, so this is an example of the contract, for example, that I was referring to. Essentially, when we have an API like this, we can see what the expected shape of the data looks like. You know, the shape of the data that the client needs to send to the API endpoint, right? And then below, we can see what an expected response might look like from the provider. So essentially, the contract here is that between the client and the provider is that if the client sends valid data of this shape, then the provider will respond with data that has this shape, right? And if for any reason the client doesn't send proper data, then it's a failure on the part of the client. And in that case, the provider will send data in this shape. But the difference is like the status code in this case, right? 200, from 200 to 299 as an HTTP code, it implies that the request was successful. You know, from 400 to 499, it means that the request was not successful and it's the client's fault. If the response was from 500 and more, it will be a failure, but the failure will be on the provider side. You know, so now that you saw that like the interactions in the contract, like the transactions, we can also see more details about the different payloads that go back and forth, right? So in this case, this is an API for uploading an image for processing, you know, so these three fields, ID, prompt, and blob, you know, they have these requirements attached to them. So in the case of the ID, yes, you have a question? Go ahead. You can ask your question, Elvia. If you're speaking, I think you're on mute. Okay. Can you guys hear me?
Yeah, we can hear you. I
Okay.
think maybe she may have issues with the phone.
Okay. So let me continue. But you can, any of you guys, you can jump in at any moment and stop me to ask any questions or clarifications. So, so I was saying that we can, the contract also shows the details about the different payloads that are sent and received, right? So this is the details of what the payload, how the payload should be structured, you know, on the client part. It's a requirement on the client. So the ID should respect that regular expression that basically says that the ID can be alphanumeric and with a maximum length of 36 characters. Okay. And the prompt should also be alphanumeric, but can also contain some dashes and underscores and things like that. And finally, the blob, which represents the content of the image, should be in the base64 format. It's an encoding, and the image type can be JPEG, PNG, GIF, or WebP. And also another requirement is that the size of the image when it's encoded to a blob string should have a maximum of 13. Let me see how many zeros. 3 zeros here. So 13,900,000. Right? We're gonna come back to that to see how we came up with this number. Okay, and the answer from the server in that case, you know, has the same requirements for the ID and prompt. And in addition to that, it also provides a response that is up to 300 characters, right? So, does it make sense so far?
So far, so good.
Okay, so that's what we saw last time. This idea that the API fulfills a contract between the server and the client. And this is one way of visualizing the contract by using this UI, which is called Swagger UI. Okay, but the contract itself is something. It's an actual document. You know, in this case, the document is in the JSON format, so it contains all of the information that we visualized here, but in the form of a giant JSON map, right? So the actual contract looks like this in the JSON format. So you can recognize the different fields as well as the requirements, you know, the regular expressions, the descriptions, and so on and so on, right? So one thing that if you are like me, who doesn't like to do tedious work, there's no way that I would want to write this by hand, right? So for that reason, last time we went through some steps using Go as a language and Q as a configuration language in order to generate this contract. So Q, I have some links. You can look at the details of Q and Go. The steps that we went through, I just happened to use Q and Go, but it's possible to do a similar approach using other stacks like Node.js, Python, and so on and so on. Okay, so we saw how to install these. We saw how to set up a quick HTTP server in Go, and then we saw how to traverse JSON objects in Go. And okay, let me skip. And then we also saw some of the syntax for Q. So the Q configuration file is very terse compared to other formats like YAML and JSON. Right? It's a bit more terse, so it's less work to write, you know, and we can easily describe the shape of data as well as the constraints on the fields for those data objects. And from that we can easily, let me scroll down. Let me see here, demos for. So from that we can easily, like this is an example of Q. So in this case, it's the same contract that we saw here, right? Q also has not only a standard library, but it also has support for adding additional Q packages that contain extra functionality. So in this contract here that we saw in JSON format, I happen to import the strings package for Q, and the strings package lets me set up some constraints on strings, you know, using some helper methods, right? So from the strings package, I have minimum runes, meaning that the minimum number of characters should be, in this case, 3. And then I also have access to maximum runes. So we have the 13 million here, right? And not only that, Q also lets us train the constraints, you know. So the way that the constraints are trained it's using these ampersand keyword. So if we look at blob, we're basically saying that blob should be a string, and in addition to that, it should be at least a string of 3 characters, and have a length of a maximum of 13 million, and also it should have that shape because it's a base 64, and we saw that the first part of that string should be data colon image slash JPEG or PNG or GIF or WebP, and then semicolon, base 64, and then comma, and then the actual base 64 string for that blob, right? So in the same manner, the prompt is a string, and it should also fulfill these requirements. So it can be 3 to, I think I need to update this. I forgot to change this, but it should be 3 to 100 characters, and it should be alphanumeric. And then we saw this one also. Okay. And so the cool thing is that with Q, we write less, but we can pack a lot of information in the small content that we have to write for the Q when we choose Q as a configuration language. So once we have Q in hand, Q was purpose built to work with the existing infrastructure tools, right? So in a world where we do a lot with JSON schemas and JSON and YAML and Kubernetes and all that stuff, right? We can easily turn Q into any of those formats. So in this specific case, we are turning Q into the equivalent YAML file, but not just any YAML, but the YAML file that has the OpenAPI structure. Okay, and the result looks like this, right? So the result includes these parts as well as the components by default. Okay, so you can directly see that this structure starts to look like this JSON object here, right? So once Q generates this, then all we have to do is to manually write the endpoints, right? So since we're building an OpenAPI and API over here, right? So in that endpoint, what do we have to specify? We specify that when we invoke this path on the API server, this path is for extracting information out of the image, and the payload should be of this shape. You see, it has a reference to this shape, and this shape is the image upload. And from the path you can see component schemas and then image upload. So components, schemas, image upload. And what do we see? We see the different properties, the ID, the prompt, and the blob. And then we can see what Q generated for us. So these runes, these strings, minimum runes, strings, maximum runes, they are being translated like this: minimum length and maximum length, right? And then the pattern and all that stuff. And same thing for the response payload, component schemas, upload status, right? And this is for the 200 responses, and the 400 responses is also this. we could have picked a different spec for a response. We have complete flexibility for that. So any questions on that?
Nope.
Okay, so let's see. Okay, so now that we have this this YAML file, we still need to have the final contract, which has this form. So in order to do that, I created a small CLI to convert YAML to JSON. I think we went over the implementation last time. So this one is called CLI.go. So this is the implementation. Okay. So since it's a command line, in this function we get the arguments that we pass it. So the arguments here are the path to the YAML file, and then the output path to the JSON file. So this one highlighted here will be generated. It doesn't exist by default. So this one, when it's transformed, the result of that transformation will generate this file, this JSON file. Okay, so that's what we have here. So at the top, I'm adding some. I'm referring to some YAML library for Go, and then using the inputs and the path to the output file, I just read the file, making sure to handle errors, and then I pass the YAML content and puts the result of that, the result of passing the YAML file into this data. And then this data can be written to JSON. So the JSON data then is used to write a new file to disk using the output file path. Okay, and then at this point we print that we successfully converted the file. And that's what we see here. So after this command runs, then we get the, oh, it doesn't show here. Let me open it here. It's a demo for, okay, so where we were. Okay, so this is the queue transformation. This is the output without the paths, like I was mentioning earlier. And then we manually add the path details. And then we convert the YAML to JSON. And then it prints, this is the output, that it successfully did that transformation. Okay, so so this is how the contract is generated. We saw that last time. So the reason why I took this approach is because most of the tools that exist out there, like there is a famous one in Python called FastAPI. If we go to learn, let's see, is there an example? It's a good example here. Okay, so when we use a tool like FastAPI, we can, a lot of those steps are done automatically. Essentially, we create the Python objects, And from creating a Python object, let's say a Python object that contains 3 fields like item ID, queue, and string. By creating a Python object, we directly end up with a UI like this. And if you notice here, the contract will also be created. The JSON contract will be created all at once. So in the discussion last time, we mentioned that a lot of these tools exist to go pretty quickly, but they are optimized for small teams or individuals. In a larger setting in which there is a need for teams to collaborate together, or even companies to collaborate, this is not sustainable, because every time the code changes, the resulting contract might also change, right? And since most of the tools available in open source, take this approach, it gives a false impression that this is the only way to do it. So in reality, these steps that I just showed to create the contract are the better approach to employ in a larger setting, because everyone has to agree on the contract first before each team goes their way to work on the implementations, whether it's building a client to invoke the API or writing the backend to implement the API server. Okay, so let me go back.
Ben, I have a question.
Yes, go ahead.
I get the contract part, but tools like Node.js do offer like a server config file where you can, also update those and then customize. I haven't, checked Fast API or Flask yet, but would that solve the problem as well?
No. So you said Node.js, right? There is one I know. I think it's called. Let me see. I forgot the name. Node.js API server. Was it first? It was something Fastify. Let me see. I forgot the name.
Express is, one of the stuff that we can also leverage to actually set up the stuff.
Right. So there are tools. Okay. So you can use Express to build an API. Definitely, you can do that. But by default, it has some missing parts. Like, you can write an API fine with Express, but you're not gonna have the contract by default. You see your contract like this, you won't have it by default. You will have to do some additional things in order to obtain the contract. And second thing, you're not gonna have the Swagger UI either.
You have to add this.
Will be, yeah. So actually, I think last time I mentioned an example of a company where I worked, and we were doing the contract first approach. We were using Express.js, right? The difference here is that we were actually writing these contracts by hand. Okay, so we have the OpenAPI specification documentation, and then we were just writing that by hand. And they had a whole review between many teams and architects to go over the contract and make sure that it fulfills all the requirements for all the teams. And then at that point, we will go ahead and implement the server. So as part of the review of the contract, we had an internal tool that was that played a similar role as the Swagger, it wasn't Swagger, it was, I forgot the name, but we will just upload the contract there, and just like in GitHub, we will mark it as ready for review and involve the different teams, the required teams that need to interact with that API, and then they will review it, add their comments and all that. So there will be like several revisions until the final contract is adopted. And once it's adopted, that's when we can start working on the implementation. You know what I mean? So because of that process that was in place, it was very difficult to just change the code and affect the contract, because the contract was pretty much set in stone.
Gotcha.
You see what I'm saying? Yeah. So the reason I showed you Q is because, like I said, this is a small API. See, there's literally just one endpoint, and then you can see how long this is. I don't know how many lines. Let me open it here. Open API JSON. Okay, so this is the same one. So just for one endpoint, we are already at 115 lines of JSON, right? Some of the APIs we worked on at that company could have like dozens of endpoints per API. Sometimes even 30 endpoints per API. So imagine the number of lines of JSON to have to write by hand. You know what I mean? Without making mistakes and stuff. So that's why I showed. That's the reason why I showed you this way of doing it with Q. Okay. So even if you're using Express and you want to adopt the contract first, you can still employ Q to generate your JSON contract, and then to integrate the to integrate the Swagger UI. It's actually very simple. So if we look here, I have an example here. Okay, all you have to do is to paste this into an HTML file. Right? It's a simple HTML file, that points to this CSS for Swagger and this JavaScript for Swagger. And in here, you just have to pass the location to that JSON contract, and then you end up having something like this. Okay.
Yeah, that's definitely much easier.
Yeah.
Because with Express and Node, we had to literally write the Swagger and everything.
Right. Right. So these other tool or similar tools as this, you just have to write codes, and magically all of those things appear. So they hide it as if it's something complicated, but it's actually very simple. Yeah. Okay. So once we have the contract, right? The contract, it's only as good as how you can enforce the contract. Okay. So for example, I think I used that example last time as well. When driving, we are supposed to stop at the red light, right? But if there's no police officers to give people traffic tickets, nobody will care. They could come up with reasons why they needed to run the red light, right? But the reason why people, feel compelled to stop at the red light, it's because they know that there are people out there that are whose role is to enforce the contract. In the same manner, when we build an API, we can have all the contracts we want, but what matters is that we need to be able to enforce it. So, so one way that we can enforce it, there are similar ways even with Node.js and Express and all that. But here, I'm showing how we can enforce it using Q itself. Okay, so the same contract that I showed. Let me scroll up. Okay, so the same contract that I showed earlier, I just copy it over into my Go app, and then I can leverage it to derive a schema as an object. And this schema as an object can be used to create a validator. Okay, and I have the entities here redefined in Go. So the image upload with ID prompt and blob, and the image upload status with ID prompt and status. Right, so those things can be validated, using the schema, which is derived from the text of the queue configuration, right? So that when we upload the image for this endpoint to process it, we can read the payload from the request, and then we can go ahead and validate it. And if for whatever reason it doesn't fulfill it doesn't meet the requirements, then we fail the request. Right, so we can quickly see it again. Let me run, I think it was demo 3. Let me run this demo over here. So let me reload. Okay, so this is another demo. In the contract, what do we have? In this contract, if I remember well, we're not supposed to have numbers in the name. Okay, so if I try it out and then, okay, so let me put some name here. Okay, let's say this is an ID, and then, okay, I just put our face. Okay, so if I run this, it's successful, right? But if I put, let's say number 2 and run it, then it fails. And what does it say? It fails, telling me that Office 2, it's not it's not a numeric. I mean, it's not a it doesn't just use the alphabet. It has a number in there, so it fails this requirement. Yeah.
Yep.
So that was the second part. We come up with the contract, but when the API is invoked, we need to somehow leverage that contract and then, I mean, we need to read that contract and then enforce the requirements. So any questions on that? So if no questions, then we can move forward. So let me rerun the demo 4. So I rerun the server, and then, okay. So we have this server, right? It's so we saw, what we just saw is on the provider side. The provider, shared the contract and has a way to enforce it. Now the client wants to to use that API and use it in a way that matches the requirements of the contract. So for that reason, I wrote that tiny UI app. I think using Node.js. Using Next.js, sorry. And let's see it in action. So okay, let me close those ones. Okay, so it's up and running. So the idea here is that we can pick an image. Okay. And when we pick an image, we can add the prompt that relates to that image. So in this case, I can say, describe this image. Okay. So the expectation is that when this image is submitted to the API will take care of, will receive both the prompt and the image as a, receive the image, inspect the image, and then come up with a description. And the description will run there below. So let's see it. Okay, so here it is. What does it say? Image description. My CSS is off. I'm not a designer. So the image is a vibrant, futuristic artwork depicting a tech hub with African influences. It features an open office space filled with people working on computers, possibly developing software or working with APIs. The setting is colorful and infused with traditional African art elements, such as tribal masks, patterns, blending, blah, 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 blah. Okay. And then it has even more details over here. But I'll skip that. When we deploy it, you'll be able to read the details for the images that you choose to upload. So let's see from a high level, how does this work? Right? We saw the UI, it's fine, but how is the data captured from the browser and then submitted? So let's inspect this. I think that's wrong one. Let me pick here. Okay, so obviously this is a form. It's an HTML form, and it contains some fields. So it has both visible and invisible and hidden fields. So the visible fields are the prompt, and the image, the file picker to select an image to process. But if you pay attention, you can also see this hidden field called image type. And you can see that it has image/webp, which is the type of image. So let me reload and redo the selection again. So if I pick this one, actually, before I pick it, you can see that this image is, this hidden field is empty. So if I pick the image, okay, so you see what happens. It has image/webp. Okay, so let me see if I can pick a different image, which is a PNG or something. Hold on. Let's think. This one. Okay, I have this PNG over here. Okay, so you can see that this time it automatically switched to image/PNG. Okay, does anyone have an idea on how this happens? No
Are
one?
you-
No
are
web developers here?
So are you either using the hash or you pretty much retrieving the file name and then just extracting the extension? Is that what you're doing?
No, not quite.
Okay.
Because okay, let me see if that works. Let me make a copy of this one. I haven't tried it, but we can find out together.
Okay.
If we go to delete, okay. So if I pick this one,
Oh, wait. You remove the dot.
oh yeah, but it actually doesn't care.
Yeah, it did. It did. Okay, so that means you're actually using the image encoding.
Yeah, so if I put WebP, for example, okay, then I do this. Okay, I think it changes. So okay, so you're right. You're right, but not quite right, because I'm not explicitly passing the extension. Basically, what the browser does is that once we pass it an image, actually, let me pick this one. Once we pass it an image, it creates I mean, in terms of code. Actually, why don't I show you the implementation? This one, I think it's photo. It's this one. So this is the form, with the hidden field, image type, and all that. So once we upload it, let me see if I'll find my code over here. Okay, so once we upload it, we have a JavaScript event handler that's looking at that file input, and the file input has a it's basically the file object. It has a field called type, right? So this type is the MIME type of the image, right? So I don't directly instruct the JavaScript code or the browser how to derive that MIME type. It happens somewhere in the browser, right? And then the browser fills that, sets that field that I can use, right? So from what we saw, it looks like the browser is using the file extension in order to derive it, but this could possibly be different from one browser to the other,
I personally think that they're using the MIME filter or the encoding. So if you search image types encoding, you're gonna see that actually, it varies based on each email, right? And then it's the first, I think it was the first 4-digit that are different. And then so let's just drop down the show more. You might see it there.
Show more.
Yep. So if you scroll down, might might actually. So for the GIF, it's yeah, I think just put types that way just to make it more.
Yeah, because this part here, data URL, this is the I'll keep this page open, but this is the when we encode it to base 64. So say type.
Types.
Type.
So image types based on encoding. So actually go. All right, go back to the browser, to the search. So just type, we're gonna type it all. Just how do you tell the image type from the base 64 encoding?
No, but for the base 64 encoding, it's known because we have to write this in front.
No, you see that ROLG, that part actually tells something. So if you type it all, you might see something like, yep, from the image encoding. You can just put image encoding. Here we go. The first 8.
Okay, so the first 8 for PNG are always.
And then so it varies for like PNG, JPEG,
Right.
stuff. So I think that's what the browser, at least the file, that type, the library leverage to actually tell which type is the image.
Yeah, but it looks like in the browser, it looks like it doesn't do that, right? Because you see, this is a PNG file, right? So it says PNG, but if I rename to, let's say, WebP, I put like to delete. Sorry, I'll do WebP.
Okay, pause. Don't keep it. No. You see, you actually allowed your computer to change the format.
Oh, I did?
Yeah, so by allowing it, that's what happened, right? So if you make a duplicate again.
Okay, so hold on. When do we get info? I'll copy it to my directory. I don't want to copy it. I'll paste it here. Okay, so instead of changing it with the OS directly, I can do it directly like this.
Okay, that works.
So now, okay, so that way the system did not affect it. But where is it? Weird, the file is not there.
Are you sorting by name?
So that added. Strange. So downloads. So say sort by name. Okay, sort by name. Where is the? Let's see if I can search it.
Here we go.
Is that the one?
I believe so. 1150. Yeah, 1150.
Okay. Okay, so if I place it here, yeah, it says WebP.
Oh, can you go back to your computer and then right click and get the info? Extension, name and extension. That's interesting. So what do they use?
No, hold on. It's because it's I think it's possible I had it as WebP directly. Let me copy it to this directory over here, just to make sure. Then I can upload from here. So let me move it to. Yeah, it still says WebP.
And you sure the command line doesn't also automatically change the extension? Maybe it does. Not just the extension, but the type. The file, I think it does. So if you just manually duplicate and then when the prompt comes, just say keep it as PNG.
Okay, so let me move it in the trash.
Yep, keep PNG. Oh, doesn't even.
Won't let me then copy.
Wow, interesting.
It just changes the file extension, but that's fine. No worries.
Yeah.
So okay. Anyway, so what's important? The browser will just figure it out and then give me the type, and then I use that type to set the hidden fields. Okay. So after that, the action process will. So after that, so when the form is finally submitted, then we call the extract image info. And if we go to the extract image info, we get the form data, and then from that we extract the different fields. So we collect the prompt, and if the prompt was somehow empty, we can default it to describe the image, and then we enhance it to. We also make an enhancement to that prompt to make sure that we get an answer in the markdown format. Okay, and we also grab the image type, and then once we make sure that the file is not empty, the file field is not empty. I mean, the image field is not empty. We grab the file, and then we get the bytes out of that file. So that file is an image. So we get the bytes of that image into a buffer. Okay, and in that case, that buffer will not be shouldn't be null unless there is a problem, and then we turn that buffer into a base 64. Okay, and now we recreate the full base 64 encoding. So it has to be data colon, the image type, semicolon, base 64, comma, and then the base 64 encoded byte. And then we use that to construct our payload. So the payload has an ID which is random, and then the prompt, which was enhanced. Okay. And then the blob, which is the contents of the image with the metadata for that contains the image type and the base64 encoding. And then we turn it into a JSON string. And then we call our endpoints to process the image, and it's a post request. So the content type has to be application JSON, and then we end up getting a response. So if there are any issues processing that image, then the response will not be okay. In that case, we throw an error. Okay, so if everything was fine, then we get the response as a JSON, and then we just returning that JSON. In the case of error, we return the error. Okay, so if I go back to this, so once the processing is successful, then we set the results, and the results are rendered over here. And since we requested that the response from the server, like the description, since we requested that the description has to be markdown, then we have this markdown renderer to make it pretty when it renders. So, yeah, any question on that? Yeah, okay. So let's look at the server implementation itself. Okay. So same thing, we talked about the schema for the server, how we run the validation. So we're handling different scenarios. Like if the request, for example, the payload is supposed to be JSON. So if it's not a well-formed JSON, for example, then we handle that error here. And if there are any validation errors for the different fields of the payload, then we handle it here. And notice that every time we respond with an HTTP code for bad request. So you can see again, bad requests, according to the RFC, this is the spec that everyone follows on the internet, right? So bad request is 400. And like I was saying earlier, you can see a lot of 400 codes, different codes for different types of errors in the 400 range, and then, from the names, you can easily understand that those are errors that come from the client. So for example, if there was some authentication requirements and the client was not fully authenticated, then most likely the status code would be HTTP 403. Whoever implements the server, has to pick the right HTTP status code for the response. So this one I've used a lot at that company that I mentioned as an example. At times, we had some endpoints that were supposed to create data, right? And if the data already exists, we need to let the clients know that by returning a 409, saying that the record you want to create already exists. It's already matching an existing record, so we can create it twice. Okay. So, or if for some reason someone writes a script and wants to abuse the service, like you can even see it when we invoke the different providers for the LLMs. If you make too many requests, you will notice that your request will start to fail. And if you inspect it, most likely you will have an HTTP code of 429. Like too many requests. So when this one is thrown, it's a way to indicate to the clients that they should chill out for a little bit. They are starting to abuse the service. Yeah, so you can go through that. It's very interesting to know. And then again, if for some reason the error is on the server side or the provider side, then the HTTP codes would be in the 500s. And then when it's the 200s, it's for successful request. So okay, or it was created, it was accepted, and so on and so on. The ones in the hundreds and the 300s, these are more like for I don't know how to describe it. Those are more for some implementation details about how we want the request to behave. So for example, if you call an endpoint and maybe that endpoint was moved to a different server with a different path, like the 301 or 302 could be used to redirect the client. Instead of failing the request, it's a way to tell the client, hey, you came to see John, but John no longer lives here. He moved to the other apartment, so go there. So some of the 300s would be used for that. For the ones in the let's say like the 101, this one is used for, yeah. So I'll give you an example for the 101. Currently, we are using the app that allows us to have this meeting, right? And a lot of those apps use a protocol called WebRTC. So the WebRTC connects all of our computers directly so that we can exchange video and audio and all that stuff. But that connection between our computers it's not instantaneous. It starts by a regular HTTP request, and then at some point, the 101 HTTP code will be used to make our machines understand that we should switch the protocol to something that's more real time, and we might switch to WebSockets or some other thing like that, which is real time, and then communicate on that. So the 101 would be used as an indication to switch protocols. So anyway, any questions on that? Okay, so let's continue. So in the case of a valid request, then what we do is that, where is that line? What we do is that our server will then turn around and invoke the LLM provider. So in this case, OpenAI. So you can see that we are using GPT-4. We set the number of tokens we want to use, and we pass it not only the prompts, but also the image URL. So the URL can be an actual URL like this. Let me see. So for example, I forgot to update this. So if I open this in a new tab, so it can be So it can be a URL like this for an image, or if we look at the previous answer from Google about image encodings, you can see that when we encode an image to base 64, with the proper metadata and all, it's still considered a URL, but a data URL. So technically, if you copy a data URL like this for an image, you can directly embed it into your HTML, and the image will be visible. That's just a side note. Okay. So once we pass that image URL, which can be an actual URL or a data URL, then let me see. So once we pass it to OpenAI, so let me see. So we have the request body here, and let me see, and we set it up as a post request, and we turn that request body into a string, and then this is the URL for OpenAI. And then we have the OpenAI key that we get from the environment variables. And also that API key is set up as a header, as a bearer token for authorization, and then content type and all. And then we actually launch the request. And then eventually we get if there are no problems, we get the response. We turn it into a string. And then the response is actually a JSON object, right? And we traverse that JSON to get the content that interests us, and then we respond with that. So when we respond with that, let's see. So when we respond with that, the description will be contained into that info object. Okay, so we use that info object to construct the image upload status. This is where we pass the ID, the prompt, and then the description back, and then we send it as JSON. Yeah. So let's see it again in action from the terminal this time. So, okay. So we have that. Okay, so we reload the server. So let's say this file. Now we do process. That's what the response was. Oh, did I miss something? Just 413. Okay. So the image size is too big, the body size. So this error doesn't come from the validation. It comes from my Next.js configuration. I think I have to address it. I'll go quickly. I'll just ask AI. I can try it. So I'm prompting Claude directly from my Emacs. Okay, so this is the setting. Valid password. Let me see. Does it have? Okay, so let's do that as suggested. So body parser. Let's put something bigger, much bigger. And we run. Okay, so let's pick that image again. Okay, describe process. Wait. Oh, I think it gave me the wrong config. Body parser. Size limits. Okay, I forgot. Let me just pick a different image just to save time. I'll look up the actual config later. So I'll go here. I'll pick something smaller for now. Okay. So it's processing. Okay, so we have the result back. Okay. And we can see it from the terminal. Those are the logs for the UI. And what do we see here? Once we encode the image, I'm printing just part of the payload for the blob. So you can see what was collected as metadata for the image. Image/webp base64, and then the base64. And then we have the random ID, the prompt, which is describe this image. And then since the prompt is enhanced, we have that additional part over here to include as much details as possible and answer in Markdown format. Okay. And then this is the response from the server. So you can see that the response is in Markdown. Okay. And then that Markdown is rendered like this at the bottom. Okay. And then the server itself, this is how what the server got. Scroll up. Okay. Okay, so let me see, what is that object? Okay. So the response is here. We can see that what the Markdown actually looks like. So it has all of those bullet points and sections. And then this one gets, packaged into a JSON and then gets sent back. So let's see. So you see that the description talks about, it says GPO. Let's see if we find it in the image. Yep, that's correct, because if you see here, we can see GPO-4. We can see that it got that from the image. Next API, next for so it got those strings, and it also got that okay, so it describes the vibe of that it discovered in the image, and then from Go APIs to AI, and then something. So it got this title. By the way, this image, as you notice, was also generated by AI. So that's why the text is like this. So pretty much from what we can see here, it's GPT-4 is better at, retrieving information from image than actually generating images. Yeah. So any questions on all of that? No questions? Am I audible still? Or? Oh, it's a very quiet group today.
Yes, you are.
Okay. So earlier I had a placeholder. I mean, like I was asking you to remember how we got that number. Let me bring it up again. Yeah, this number. So 13,900,000. Okay. So this number comes from this. It's it's quite a simple calculation. You can encourage you to do your research and I mean, call me out if I made a mistake. But if I'm not mistaken from what I understood, the image, actually any file on your system, when it's like any file on your system is usually in the binary format, especially for things like images, right? Some other files could be considered plain text. Like, for example, if you create a document with Notepad or VI and so on and so on, right? So in either case, whether it's a binary format like an image or video and things like that, what's for sure is that at the end of the day, every file on your system has a binary like representation. I mean, can be represented as bytes. Okay, so that includes files like images and also text. So a byte. So this is the calculation for a byte. So the calculation goes as such. If we have 10 megabytes, so you can imagine if you have an image which is 10 megabytes, those 10 megabytes, when we expand them, 10 MB corresponds to 10 times 1024 times 1024, which comes up to 10,485 and 760 bytes. Okay, and if that was the size of the image that we obtain, what happens when we convert it to base 64? Once we convert it to base 64, the new size would be this number of bytes multiplied by 4 and divided by 3. Okay. So if we start with 10,485,760, we come up with this number, which is 13,981 and then 16 bytes. Okay, so you can see that this number is very close to what we set up here. Okay, so it means that a 10 megabyte, if we start with a 10 megabyte file or image, after doing the base 64 encoding, we end up with a string that has approximately that length. And the more exact number for that length is here in terms of number of bytes. Okay. So here I picked a smaller number, which is all round, just because it's easier to write. And so so because I've picked this number, it's as if at the API level, I'm restricting the number, the size of the image that can be processed. You know, because when we create APIs, it's important to have these restrictions to avoid ill-intended clients, you know, to avoid them breaking the service. Okay, so it means that this API can process images which are up to just under 10 megabytes. If it's anything more, it will break. Just like we saw earlier, looking at the UI logs, you saw that when the image was even larger than 1 meg, the UI started complaining because by default it's set up to handle up to 1 megabyte size of images, you know, or payloads. Okay. It doesn't mean that the server cannot process more, but this is, you know, we have to set a number and then go from there. Okay. So any question on that? Okay, so if there are no questions, then we can go ahead and work on the quickly work on the deployment. So the deployment is actually simple because I'm using a different cloud provider this time, so that I can just package both the front end and the back end as Docker images, you know, push them to the registry of the provider I'm going to use, and then find a way to link them. So the linking part has to do with this. The client, you can see that the client is grabbing the server URL from the environment. Okay. And at the same time, when we look at the server itself is grabbing the key, the OpenAPI key from the environment. So it means that in both cases, whether it's the server URL or the OpenAPI key, those things are not hard-coded in code. You know, so after we package both apps and push them to the registry, before proceeding to the deployment, we need to set up those environment variables for both the server and the client. So let's start by the server. Let's see, I think I have, oh wait. There are some Docker files that I worked on to save some time. So demo 4. Okay. So let's see what it looks like. Docker file. Okay. So I'm using Go version 1.23, 23.3. So for that reason, I picked the same image as a builder image. Okay, and then I'll go ahead and install some dependencies. I will have shown you why I'm installing those, but just to save some time, I'll skip them from now. And if you want, we can revisit that after. So the first stage is to build the application. And then after the application is built, we end up with a single file called app. So we copy that app file from the previous stage into the final stage, which is an image, which is a scratch image. It's basically a Docker file with pretty much nothing in it. So that Docker file will only contain the app as well as the certificates. And then we just run it because it's an executable file. Any question on that? Okay. So now I'm going to copy the Go mod and Go sum. These ones contain the dependencies, the list of dependencies that should also be installed. So same as the Docker file, I'll copy them to the folder. Just to make sure. Okay, so I think this is all we need here. So for deployment, I'm going to use fly.io. So let me go here, fly. Go to the dashboard. I don't usually use it, but it's a fun tool to use to quickly experiment. So this is what my dashboard is. You see, I barely used it. I'll probably used 1 cent out of my $5. Okay, so
is it a cloud provider?
Yes, it's the same deal as Vercel or Heroku and so on and so on. They work on top of existing providers. So I'm pretty sure behind the scenes they must be using one of the big three or all of them.
Got it.
The reason why Fly.io is cool and a little bit different is that for their container engines, they use Firecracker. So Firecracker is the same thing that powers AWS Lambdas. So it's pretty snappy, as they say. So I have the CLI for Fly already installed. So when I do Fly launch, it's gonna discover that I'm using. I want to package the app as Docker, and from the go.mod and go.sum. Actually, I can show you what they look like. Yeah, so the Go mod is this. So you can see the Go version is specified. The module name for my app is specified. I require these two dependencies and then some additional ones here. I'm not using all of them, but I install them anyway because, yeah. But my direct dependencies are these two, and those are transitive dependencies. Okay.
Thank you.
So from the presence of the Docker file as well as the go.mod and then the go.sum, the go.sum is once we install, it contains the actual details about the versions, all of the necessary details. It's similar to pip. When you install pip, you do the pip install and all that, you have a log file somewhere, or same as Node.js. When you have the package.json, but when you install, you have a package log.json. It's the similar thing here, the go.sum.
Okay.
So Fly launch will, yeah, go ahead.
I remember last time you talked about Go being being able to deploy Go as a single binary file, or like what do you call that, a compiled file that contains all the dependencies and everything.
Yeah, that's what I showed you here. So, okay, let me build it locally first.
Mhm.
So if I do go build, and okay, I'll skip the additional flags are to reduce the size of the binary and also, I mean, make it static. Okay, so actually, let me include them because why not? So if I put these, okay, and then I build the demo form. Demo form. This one is demo. Okay, so if I do ls, you can see we have a demo 4 over here, right? So if I check the file, you can see that it's an executable file.
Got it.
Right, and then I think if I do O2, yes, is that the right command? I forgot. Let me check. Mac OS. Set O2. Okay, so it would run. Okay. So you can see that I built it for, I built it for my machine. So it's a typical Mac binary, right? And on Mac, it still has these dependencies, but hold on. Let me see if I can build it for Go. I think is it Go or OS? Go branch. Go branch. Okay, I think I can cross compile it like this. This one I think is AMD 64. And then I'll put it to demo for Linux 64. Okay, let's try that.
You need a space between the static and the O, the dash O.
I'm going to help builds. Let me see. Output. So grab output. I forgot my commands. Go build output file. Oh, so it's dash O. So why is it complaining then?
Like you don't have a space. You see the after the static.
Oh, okay. Okay, so let me do that again. Okay. That was that. Okay, so it's done building. So you can see now we have demo for Linux, right? So if we inspect the file type, you see now it's a Linux binary. It's an ELF file. Okay.
Got it.
And then if we do O2, okay, so you see this one is self-contained. On Mac OS, if I'm not mistaken, Go has a hard time building fully static binaries. But you see, when I compile for Linux, you can see that it's standalone, right?
Mm-hmm.
So it depends, it has no runtime dependencies at all. It's just one file. And if we want to see the size, we can do this one. So it's a 12 megabyte size. So again, going back to the Docker file, this is essentially what we did. We set it up for production, and we want it to be static. And this is the first stage, right? And from that first stage, we copy the binary file. You see the -o is that app over here, right? So when we copy it, we just have this. So literally, we have the CA certificates as well as the time zone details. Those are just configuration files pretty much. And then we have the app. And then the container itself is from scratch. So there's nothing in the container apart these three things.
Got you. Okay, now I got it. I thought you needed the container. You needed Docker to actually be able to compile, go into one single binary file.
No, we don't need that that's what I
Yeah.
was saying, like what I showed you here, and I cross-compile for Linux. Literally, that at some point, that's what I was doing for my shared hosting service. If I wanted to deploy a website, I will just compile this one over here, upload it to my shared hosting, put it behind Apache, and it works.
Nice.
Okay. So it was funny because people would FTP giant PHP apps with hundreds of files. For me, it was just one file. So there's no way to make a mistake.
Yeah.
And the crazy thing also is that not only we can compile to a single file, but if you have some static assets like CSS images, I don't know, HTML files, all that stuff, you can embed them into that single file. So for example, I compiled the demo for Mac, right? You can see it's just that file. Okay. So if I go back and reload this, you can see that it still works. Right? And not only it still works, but we still have the contract. Even though when I do ls, you see there's no contract file in that folder. How come?
Wow, that's crazy. That's
the reason why it's possible is because Go has a feature called embed, which is part of the Go standard library. And in that embed, you see this code over here. I tell it to embed the current folder. Okay. And once I embed the current folder, let me see, where is the... So once I embed the current folder, that current folder is, I pass it to that content, right? It's this one. And it has the annotation to embed the current folder. So that content becomes like a virtual file system. And that file system lives inside the app. So it will literally copy the content of the current folder where that source file is located into the binary. And then when we want to serve that JSON file, you see, we get a hold of that virtual file system and we read the file, we read the JSON file. You know, so if I rerun this, that OpenAPI JSON file is embedded into that demo 4 binary. And then we read it from the virtual file system, which is the binary itself. And then we can serve it like this one. Does it make sense?
It does, yeah.
Yeah.
How do you handle logging?
It has a logger package inside. You can use logger libraries, or you can use what's provided directly. It has a logging package over here. Usually people use third-party, people have been using third-party logger libraries. It's because up until, I think, Go 122 or Go 123, the logging package was either not available or it wasn't good. But now it's usable. So you want to become a good developer now?
Yeah, it looks like I'm sold. You know?
Yeah, so like I was telling you, that single file, when I used shared hosting, contained all my CSS, all my JavaScript, all my HTML templates, like everything, my SQL files, everything in a single binary. And I upload that one file to shared hosting, put it behind Apache, because that's what the shared hosting providers, give as a service, right? And then it just worked. It was literally that easy. Anyway.
Yeah, thanks much.
Yeah, I mean, it's possible to do that with other stacks as well. I think Rust can do it now. It's not quite as slick as what Go does, but it's possible to do it. It's also possible to do it with Java, because now we can compile Java to single files, But
It's
I think
Go of the single binary, the speed, and also, like handling everything at the same time that is impressive for Go, like for me.
Yep. Now you understand why people use Go for a lot of infrastructure, right? Like Kubernetes is written in Go. There's a bunch of I forgot the name. I mean, there's a bunch of tools for infrastructure that are written in Go, and for that specific reason.
Yeah, and
okay. So if I go back, let me delete those. Demo for Linux. Yeah, so like I said, it's possible to do it with other stacks. I think nowadays Java can compile to a single file as well with things like GraalVM. But it's a topic for another day. I'll show you another day. Okay, so now that we have enough things to help the fly.io CLI, it's gonna detect that this is a Go app, and it's also going to understand the provided Docker file. Even if the Docker file was not provided, by just having go.mod and go.sum, it will understand that this is a Go app and then build it accordingly. But okay, so let me do this. So you can see it detected the Docker file, right? And I'll just keep the defaults. So I'll do enter. And now it's gonna start building. So what happened is that it generated a config file for fly called fly.thermal on the fly. I mean, it's a lot of flies. It's a coincidence, but and then once it generated that fly.thermal config file, it also took care of uploading the application into fly.io. And then from there, it triggered the CI build. And then it sends us back the builds over here, the build logs over here. And I think we can probably see that. It reloads. Yeah, so we see demo 4. So we do live logs. Okay, maybe activity. Yeah, so this is the one. Okay, I think the build is probably done. Oh, okay, it's already done. So now that the build is done, we can launch the app. No, sorry. It's fly deploy. We can deploy the app. You can tell I don't use fly.io that often, so I probably did an extra step, which is not necessary, but it's okay. Let's wait for it to be done. Okay, so it gives us this URL to access the app. So actually, let me share the URL with you as well. Okay, so if you use that URL, oh no, we have a 404. That's okay because there's nothing handling any requests there. Because the URLs that we handle are /docs /openapi.json and then /extract image info. So if we want to see the docs, we just go to docs. And then we end up having the same thing as earlier, right? Those are the Swagger docs. Okay. Okay, so now let's go ahead and deploy the UI. So for the UI, let me remove this one. So for the UI, I also prepared another Docker file for the UI. Okay, here it is. Okay, same deal. It's actually, let me take that back. I didn't write this one by hand. I usually write mine a slightly different way, but when I was trying earlier, like I said, in this case, this is a Next.js app, right? So fly.io, when I tried earlier, detected that this is a Next.js app, and then it generated that Docker file that I kept around. So I just reused that. Because when I set up my Docker file for Next.js, I have a slightly different approach. So, but anyway, essentially it copies all the assets, all the artifacts for the app, okay, as a base build. And so the base is pretty much like an Ubuntu system, operating system. So it installs, some basic dependencies that are required for running the build, right? And Let me see. So it's reusing bun just because on my system I have a bun.log file. So that's how it knows that I should use that it should use bun as a JavaScript runtime here. Okay, so it builds, installs everything, blah blah blah, and then runs the app using the start target. You know, so we look at the package.json. See, it's running this one, which is just next start. So bun start we call next start. Yeah. Okay, so we can deploy it. So same thing, we can just do fly launch. Keep the settings and then create Docker. Okay, I just keep the defaults. So. Any other questions or comments?
The Java binary compiler that you mentioned, is it Grail VM?
Yes, Graal VM, yes.
Okay, thank you.
Yeah. The only thing is that it takes a while to. I mean, they're improving the compilation time, but it's still very slow. At some point, that's how I ended up with a large build for my CI builds in the cloud. You know, so when I saw that, I was like, no way. Then I started running my builds on my machine instead. You know, so be careful.
Got you. Maybe one fun project is to rebuild the whole Ubuntu TechHive using Golang.
Oh man, maybe you haven't noticed, but I built it in Go. I have many or several implementations of the Ubuntu TechHive site. You know, some in Golang, some in.
Got you.
Oh, great. I think it's complaining about, oh, I have these files. I need to delete them. I was experimenting something this morning, but so these ones are not. I should get rid of these ones. I wanted to show you a different feature for streaming, but I haven't got it working properly yet. So we can revisit that some other time. Okay, so let's try again. That's what it was complaining about. Yeah, so I was saying that I have several implementation of the Ubuntu site. I mean, part of the reason is that I'm also experimenting with different things. You know, since this is not really like, as of now, it's not a production app to do anything like serious. It's just for play. You know, so I had some implementation using name at the beginning, like this one, name as a language. This one looks like Python, but it compiles to a single binary as well. You know, and you can easily reuse C and C++. If I'm not mistaken, you can also embed assets just like in Golang. You know, so I had a name implementation. At some point, I had a quick implementation like this one, right? I mean, I had several. Currently, it's running Clojure. These sites. So It's running Clojure, my own framework, if I can say. You know, it's not really a framework, really. It's just, I mean, if you see it, you gotta run. It's a lot of crazy experimentations. Yeah.
Someday you're not allowed to call me a lab rat anymore. I found the true lab rat.
Oh man,
I totally agree.
I can't remember if it was Aziz or Derek one day that asked me, "Hey, can we collab on the site?" I'm like, "Man, you don't want to do that." You're gonna see some stuff that will trouble your sleep.
Probably me.
Okay, so it's up and running. Let's copy this one. It's okay. Hey, it's up there. So there's actually something wrong with it, but I'll let you guess. Can you tell me what step did I miss? If you are paying attention. Okay. Okay, let me bring up the logs for Fly. So those are the Fly logs for the server, and then for the front end. Okay. So you can see 3,000, blah, blah, blah. So, and then the server. So can anyone guess what I missed?
So the only thing I can think of is that on the second part, you just went with fly launch. You did not do the build, but I don't know if that was necessary.
Yeah, that's why I was saying I don't use Fly that much. I can't remember the difference between launch and deploy, but I think for new projects, the first time it has to be Fly launch, and then subsequent times maybe Fly deploy. I forgot one of the two. But that's not it. It has to do with how the app works. Should I run it?
Can you refresh it, please? Can you refresh it? The browser. Yep.
Yeah.
Yeah.
Well, let me share the URL as well, so you can try it out. So you don't know what I missed?
Perfect. Let's check the URL.
Okay, so let me run it. So describe image, run. Oop, it failed. Let me try again. Describe process, it failed. Okay, why it doesn't work? Let's look at the network tab. So describe process. Do you get a clue of why it doesn't work?
Oh, you have the inspector out. Okay, let's check it out.
Yeah, you can see it, right?
Yep.
What does it say? So we deployed two apps, right? One is using the other, right?
Yeah.
And this is your clue.
Oh, so you didn't provide the correct URL for the second one, for the first one?
What URL?
The API URL.
Yes, exactly. So we deployed two apps, but we never specified how the UI is supposed to find the backend. So we can see it from the logs, right? This is the API logs. You can see that no requests came through. But for the UI, we can see, we can see that it processed the image, turned it into base 64, but then nothing after that. Instead, we can see this error. We can see that it's trying to invoke the extract image info on the local host port 8080. And we know that this is not the case, right? There's the server is definitely not running on localhost. So this URL is wrong, you know? And if I do process image, so we can see that in the process image, extract image info, we are referring to API endpoints as an environment variable. And that environment variable is the one that contains the actual URL to the server. And if this is not found, then it defaults to localhost port 80. You know, so localhost port 80 is not available, so it fails. So what do we need to do? We need to specify this API endpoint. Okay, so to do that, we just need to pass the URL to the server, right? So the server is this one, demo4.fly.dev. Okay, so demo4.fly.dev. So the CLI command is for secrets. So fly secrets, and then we set that API endpoint, and then we set it to equal this URL. So if we do this, it's gonna update the deployment with that information. Okay, I don't know why it's so slow. Earlier this morning it was quite snappy. Anyway, so it's up and running. 1302. So if I bring up the logs again. Okay, so those are the previous failures, and then we can see that it restarted the app. Okay, so let's try it again. So if I reload, pick an image. Now we can say describe it, process. What happened this time? What happened this time? This time we have an empty response. And the server actually received the request.
Is your what do you call that? The ChatGPT thing set up on the server?
Exactly. That's what we need to do. So the same thing, the same way that we are referring to an environment variable, it's the same way that for the ChatGPT, the server requires the OpenAI API key as an environment variable. So we need to set it up. So on my system, I have all of these environment variables set up. So the one that we need is this one. Okay. Okay, so same command, fly secrets, then we set the OpenAI API key, right? And then I refer to the one that's set up on my machine by placing the $ in front so that I don't expose it to anyone. So if I do the same thing, enter, it's gonna set it up.
While this is running, I have a question. So
Yeah.
you have the API running on the same instance as the app itself, or are they on different instances?
Oh, you mean like the web app? No, there are
Yeah.
different instances.
Okay.
So if you look at the dashboard over here,
Mhm.
it loads. Yeah, I don't know why the app is so slow today. But it's
Maybe
coming.
because they're trying to make you pay more money.
Yeah. So see, the backend is deployed on 2 machines,
Mhm.
which are different than the front end, which is also deployed on 2 machines.
Got it. And you pay the same amount regardless of how many instances you have. The same
No,
cost.
they charge accordingly.
Oh, okay.
You
Get it.
the more you have, the more you pay. So,
Yeah. I thought I discovered something cheap.
yeah. There's nothing free, man, especially when it comes to the cloud.
Yeah.
You only have like cheaper and more expensive, depending on your choices, but nothing free. Okay, so we can see that it restarted the app. Okay, so we can try again. So if I go to the UI, reload this. We'll pick this one. And then describe, run this. Okay, you can see that this time it's processing. And yep, we have the description. Worked. And we can confirm the same thing from the logs. Say this image seems to encapsulate blah 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 technology integrated into daily human life. Blah, blah, blah. And then we can see the same thing here. So that's the markdown. And then the client logs, we receive the markdown. This is this block over here. Yep.
All right. Another question.
Go ahead. Yes.
So I know for sure that OpenAI will return the response as an array of strings, right?
As
So
an array of strings.
yes. So like you see where it's saying that this image is like the overall atmosphere blends futuristic and all that. So it breaks it into like messages from the OpenAI side. Now on your API awaits for everything, then creates one single string and then sends it to the front end, right? My question now
Okay,
is,
go on.
if that message was super long, right? Let's say you're processing a whole book of multiple pages. Is there a way to actually mimic that same thing where whenever OpenAI returns the value, you just forward it to the front end and then you just keep doing that? I know it's not efficient, right? But is there a way to handle it that way?
Yes, there is. So actually, the part that I deleted like a few minutes ago, that was the second part that I wanted to implement that ran out of time. So,
Oh, the streaming part.
for your question regarding the OpenAI, I think you are referring to streaming the responses.
Exactly. Yeah.
Yeah, so streaming the responses, I don't think this is what it does by default. By default, it sends a whole block of text. You can see that in my API call over here. Okay, So here, when I make the, wait, let me see. Okay, so it's this method over here. So this is the payload, okay? And I launched the request here after doing all this setup. And you can see that I get the whole body all at once. You know, so I'm not really concatenating strings before sending back to the client. I just get the whole thing in one block. In order to get the streaming, you need to add inside the payload the fields to indicate that you want a streaming response.
Okay, that's probably what on my code.
Yes, and then in that case, you have the freedom to stream it to the clients. So let me see. I think, let me see, is it the one conversation? Okay, let me run this one. This is an example. So we'll run demos. Okay, so let me open it on the side. So conversation. I forgot what I did. Oh, okay. So I have the streaming conversation. Okay, hold on. Streaming conversation. It's a bit slow. I think I have some timers in there. Okay, so it started coming. So you can see that the response is coming like piece by piece, right? So it's definitely possible to do that, because to send that response piece by piece, I'm using the it's a feature of HTTP. It's called server sent events. You know, so you can see the events here in the network tab, right? You can see the event ID, the event type, and then the actual payload, which is that those divs, the HTML divs, and then the timestamp, right? So when you indicate that you want a streaming response, you know, to OpenAI, most likely they will send the response in chunks using using server sent events, right? And then as you get them, you can also start a server sent event stream back to the client and send it to the client piece by piece as you get it. And then the client in turn can also stream the response from the server to the front end using the same protocol of server sent events, so that just like when you go to chatgpt.com, you can see each word appear one at a time.
Okay, and you said that the streaming is not the default setup for OpenAI, right?
Yeah, the streaming is not the default, because what happens is that if you go back to demo 4, in demo 4, you can see I'm specifying like the maximum number of tokens, right? So it's gonna build all the response on the OpenAI side and send it to me in one block, you know, for a size which is less than or equal to this number of tokens. You know, so if the actual response was larger, it will cut the string.
Yep.
You know, after 496.
Okay.
So
Thank you.
Yep. Any other questions? have you guys tried the URLs that are shared or?
Oh yeah, I tried it.
Yep. So that's pretty much it for the demo.